And today is the Geothermal Energy on your chapter 13. Okay, so geothermal energy is nothing but the energy from your ground, okay, from the earth, from the like deeper part of your earth, and we can be able to harvest the energy, okay, from the earth. Right now, today, in recent years, geothermal energy we use it for ground source heat pumps. But then we have problems, problem with access, because it's really difficult to dig into the ground, and you need technology, you need labor, and you need money, okay, to construct these systems. Okay, so the Earth geological structure, you don't have to go into details if you can get the crust, the outermost layer, and then the mantle, the middle layer, and then the core, okay, inner layer, inner outer layer. This is inner layer, which is your inner core, okay. So if you get the three, you should be okay, okay. Okay, and we're gonna continue the Earth structure. So pay attention, right? The thickness is 3 to 35 k mile. This is mile. And then your temperature increases as you go deeper. The temperature of shallow crust, right? So that's right here. It's about 13 to 24 degrees C. And then up to 8,000 degrees Celsius, you can go into the molten core. So about 4,000 miles, okay? You gotta go all the way to the center of the core, okay? Okay, so if you take a look at the history, so that's like about 10,000 years ago, right? So Paleo Indians, right? They started out the geothermal energy, like they discovered that, all right? And also Romans, right? They don't know, of course, as a geothermal energy. They only know just like, okay, hot water coming out of the ground. You can be able to feel the earth is hot in certain area, right? So that's how we come to know the spark and also the hot spring, okay, hot running water. In 1800s, early 1800s, so that's over there in Yellowstone, okay, in Wyoming. So hot spring and also the hot spring in Arkansas, yeah. In 1852, right, so somebody opened the resort by using the heat, okay, water, hot water from the ground, so geysers resort in San Francisco. And then 108 years later, we got the first geothermal electricity plant, okay, in California, of course. Okay, so geothermal sources, this can be resources, the same thing. So we have temperature, okay, we have physical state of water, because usually water or steam, right, coming out from the earth, and the type of energy used. So we have three things that we consider for geothermal sources: temperature, physical state, is it steam or is it water, okay, and type of energy used. Primary temperature classification. So when you take a look at the low temperature reservoir, that's about like 50 to 200 degree Fahrenheit. in degrees Celsius 10 to 94, and high temperature reservoir that's over 200 degree Fahrenheit. Okay. Okay. So geothermal resources or geothermal sources. So first we have like the hot water reservoir. So they are reservoirs of hot underground water. Okay. And we have many in the United States, all over the country, but they're more suited for space heating, okay, than for electricity production. I mean, like it's not very easy to generate electricity by using these reservoirs, but you can use for space heating. Natural steam reservoirs is a hole right dug into the ground, and you can use the steam coming out of that right to the surface. But this is you can't find everywhere in the United States like the hot water reservoirs. Geopressure reservoirs, so another resources is your brain completely saturated, okay, with natural gas, and then it is stored under pressure, of course, from the weight of rocks, okay, overlying rocks. We use this type of reservoir for heating and also for getting natural gas. Okay, so normal geothermal gradients. Okay, so that gradient meaning like like as you dig into the earth, you're gonna get the temperature increase, and that temperature increases every kilometer you dig. You got 300 degrees Celsius up. Okay, so if you dig to 20,000 feet, you get 1900 degrees Celsius, all right, of temperature at that level of the earth. Okay, so of course you calculate or you count this temperature from your surface temperature, and that's enough to produce the electricity. So we don't have the technology, not enough technology, okay, meaning like not economical technology to be able to extract right this type of energy. The next one is your hot dry rock, and this type, like we have about 5%, right, in the US, and that's like similar to normal geothermal gradient, okay, but that gradient is like 400 degrees Celsius every kilometer you dig into the ground. And the last one is your molten magma. We don't have the technology. You can see, right, molten magma sources in Alaska and Hawaii. Okay. Right, so this is just showing you your geothermal resources in the United States. And when you take a look at the ground temperature, okay, in these areas, so go by different states right here, you know that you can be able to get right pretty good geothermal energy right here because that's like about 200 degrees Celsius. And then as the color, okay, going from red all the way to green, the temperature reduces. Okay, so if you want to harvest the energy, we gotta hit these states, right? And this is the global map, and you can be able to see which country, right, we can use to harvest the energy. And we have Europe, okay, here, and then Asia right there, and then Africa, and you have North America, okay, United States right there, and then the South America, okay. And these parts are cooler. Of course, you can locate the geothermal sources hot spring, okay, geysers, hot rocks, right? These are great resources. Some more. This one is in California, and then that one is in New Zealand. Okay, you can see the hot steam, right? Coming out from this ground. And this is a geothermal energy system or plant or facility. So they harvest the energy from the ground, okay? And it's a very huge system, by the way. And we can be able to use that energy, okay, in industries. Geothermal heat pumps, just the very most basic form, right? Geothermal that you use in residential places. You can take advantage, right, of your store heat, and you can store it in near surface soil, okay? Temperature about 55 to 75 degree Fahrenheit, so it's not very hot, okay? It's kind of like a warm temperature. And in winter months, you can use the ground as a heat source, okay, to heat up here your house, and then transfer the heat, okay, from the warm subsurface to your house, okay, or facility. So in summer month, we're gonna use the ground as a heat sink, okay, because we want to cool it down. And it's kind of like a reverse to this, okay, process. So transfer the heat from the facility or your house into the ground, okay. So this side heating it up, and this side cooling it down, okay. That's for winter. Winter, we heat it up, so heat is absorbed from the earth. Summer, we're cooling it down, so therefore heat is discharged into the earth. We're going to take a closer look, and we have three parts, alright, in geothermal heat pumps. You have underground piping, and you have the pump, and that's your heat exchanger system, okay, pumping the heat in and out, and then your indoor distribution system right there, which is right here that you can see in the diagram. So heat pumps are pretty good because you're using the natural heat instead of, okay, burning something to get the heat out of it. Okay, power plants. It's nothing but we're using the heat from the ground, alright, to produce the electricity. So geysers is the largest producer for geothermal power, okay, in the world. So there are different types, right, of geothermal power plants. So there are dry steam system, you have flash steam system, and then your binary cycle systems. So you need different types, right, in order to take um, um, different heat amount that you can be able to get from this site. Okay, so it depends on the location, and also how powerful the heat is under that site, okay, under that ground. So it depends on the amount and intensity of heat underground. You're gonna have to apply a different system. So dry steam power plants, we use a geothermal steam. So basically you're using the steam, right, from the ground to turn the turbines, yeah? Because you always need some form of force or energy to turn, all right, these blades. And then once you get the mechanical energy at the turbine, we can use that, all right, to run the generator to produce electricity. And the only thing is you will have to remove the rock, okay, from the steam because it can mess up the blade right here. So before entering the turbine, you gotta get rid of, filter all of the little rock, right, chips out. And what about the emission, right, from this system? So emission from the steam system is your water vapor, because steam is a water vapor, yeah, so they can leak out. Okay, so this is single flash power plant is your dry steam system. So we can see, right, this diagram, be able to understand how that system works. Okay, so you have your production well, right, and the heat. See the color, yeah, we have orange and then we have yellow. And you're going to separate steam from water, get into the turbine, turn the blades, and then run the generator, produce the electricity, yeah. Your waste is going to come out this way, yeah, and then going back into the injection well. Okay. So flash steam systems, so that's your second, right, type. And when you take a look at it, you can see the production well is here, right, and then you have your flash tank, your turbines right there, and then your generator, and the electricity is going to come out, and then your waste is going to go back into the injection well, yeah. So how do we get the energy is because you have a very high pressure, right, water, and that is going to go into the low pressure, right, tank. So that process definitely flash, all right, turn the water into steam. So we're using the pressure differences, okay, in order to get steam out of water and then to turn the turbines. Yeah, so this is steam, that's water. And excess water, of course, is going to go back into your injection well. Okay, so flash steam system, they're very common plants or common systems, and they're going to pull the water, okay, very, very hot water, high pressure water, and the temperature is about 3,600 degrees Fahrenheit, right, to the surface. We pull it out. And then we're going to turn that into steam, okay, and then run the turbine, so you know the process. So this is just a picture of your steamboat screen, okay, in a Nevada plant. Alright, so this is your flash system, right, steam systems. So you can see right here production well, and the heat come up, and then we're going to separate the steam out of water by using this heat, okay, and then that steam is going to go into the turbine, and then we're going to use that mechanical energy, alright, to run this generator and produce electricity. Excess steam is going to come back down, right, all the way down, okay, into the injection well. Yeah. Your wastewater also can be able to come out from your separation chamber back, right, to here, or go to the heat user, okay, because we're using the heat anyway. This is very hot system, by the way. Even if it is yellow, you still have to use a cooling, alright, tower with water, of course. So this is your cooling system to bring, alright, that temperature down, so that you can be able to use that balance, alright, heat or adjust the heat for the customers and the users. Yeah. Alright, so another system is your binary geothermal system. So here the system, we use the hot water, same thing, okay, hot geothermal water. But then we have a secondary liquid, right, that goes with it. So that secondary liquid, they have like a lower boiling point than our primary, okay, hot water from the ground. So the resulting steam, of course, is going to go into your turbine, yeah. And one thing good about this, alright, system is the process, right? It doesn't produce the emission, so that's a good thing. And temperature needed for the water is also low. Okay. The same thing, production well coming up. We have a secondary liquid, and this is your organic liquid. It's going to produce a steam. Steam is going to drive the turbine turbine, mechanical energy is going to run the generator, and then you're going to get the electricity. Okay, excess is going to go back into your injection well, yeah. And this component, right, is this binary geothermal system design, right? And we call that the heat exchanger. Binary systems are very good. They have higher capital investment and they need high efficiency equipment. Okay, equipment, facility, construction, that's all pretty costly. And water, right, is going to return back to the reservoir so you can use it. And then the best thing is there's no emission. Yeah. Another diagram for your binary. So production will go up. Heat exchanger is the key point for your binary geothermal system. Now there's your secondary liquids here, right, exchanging. And then we've got your organic vapor. Heat exchange me on getting a lower temperature on a state. Turn the turbine. Turbine is going to run the generator. And then you're going to get your electricity. Excess temperature, we're going to bring that down, okay, by using the cooling system. And here we're using the air and water cooling system. And you're going to get air and water vapor out, alright? Zero other emissions. And cool water is going to go back down into the injection well. And that's your reservoir, so that will recycle and come back into your production well. Okay, so the geothermal energy, environmentally very attractive, yeah. But again, locations, yeah. What's underneath of the ground is very important, and the temperature, yeah, we gotta consider. But of course, it can never be the main energy source because of the design is difficult, construction is difficult, also location is the limitation. So therefore, it can remain as an addition, all right, to other large energy sources. And the bottleneck or barriers, all right, difficulties or limitation is because of the risk, yeah, because we're dealing with hot, right, steam or hot water coming out of the ground. So if the system configuration is not carefully designed, there is a big risk, okay, because you're dealing with high pressure and high temperature water and steam out of the earth, okay. And then cost, right, capital. So these are the limitations or downsides. So if you take a look at the cost, right, costs vary by location or site. High exploration, all right, costs before you, all right, construct the plant. You have to explore that site. Very high initial, right, investment capital, but with low operating costs, because once you build it, you can use it. And the fuel is definitely free because that's just the water, okay, or steam out of the ground, mostly water, hot water. We only play with the temperature up and down, right? Adjust it if you remember. So temperature and depth of resource is very important because that's how you can be able to get the right amount of heat, okay? You have to control the temperature. Definitely resources are available, right? Even if they are localized. And we also have to consider the science and technology of the plant facility. Yeah, this is reiterating, okay, location or resource. So when we take a look at the geothermal energy, we see geothermal production of energy is the third highest among the renewable energies. Okay. Of course, you have hydro, and then you have biomass, but it comes before the solar and wind. So you've got hydro, and then bio, and then you have geo, and then it's solar, and then wind. Okay? The misconception is if you think about renewable, you count only solar and wind first, and you forget all of hydro and bio and geo. Okay? So pay attention in your quiz and final exam. Capital cost, very significant initial investment, okay, but operation is kind of low. Just showing you your geothermal energy, okay, potential, and here is your US map. So I'm not going to go over it. All you need to do is go to the PowerPoint, okay. I give you the PDF copy of it, and you can be able to make it bigger and read it. Yeah. Just go by the color. If you can get right this green part, we already right take a look at the previous diagram already, and you know that the geothermal sources completely all potential, yeah, concentrated around here, yeah. So if you get that point, you're okay. So if I give you like Texas, or if I give you like a state here, you understand that they're not very good resources for geothermal energy. If I give you a state here on this side, yeah, to the west side, then you know that they're good, yeah, for geothermal energy, like your Arizona, okay, California, and Colorado, yeah, here, and Utah, yeah, and New Mexico right there somewhere. So make sure you get all of that, okay? And the same thing, give you 2 links. Visit, alright? Don't be limited to only 2 links. Just go ahead and browse, alright? Google search it, and there are thousands of videos, okay, gonna assist you for your learning, and make sure you do that. Okay, I'm gonna go ahead and stop here. But for exams and quizzes, make sure you stick to the handouts, yeah? So you still need to have your foundation, you need the basic information, okay, not all the stuff outside. Stuff outside looks very attractive, but then sometimes they carry misinformation, okay? Most of them are good, okay, acceptable, but make sure you stick to the handouts and a textbook for quiz and final exam. Alright, that's it.